right, once you're done with your daily Q, please go ahead and get your notes out. We are going to talk about the last two sections of the chapter. So in theory, you're familiar with some of the minor concepts behind the different types of reactions as well as the types themselves. But we are going to go over and talk a little bit more about what they are and what they mean. There are, of course, 5. For us to discuss here. There are really more than 5 types of reactions, but for our purposes, we simplify them into 5 categories. The first of which are the synthesis reactions. Those synthesis reactions being also referred to as composition or combination reactions. This is where 2 or more substances combine to form one final substance. I will remind you of all of those rules we discussed previously about things like what dictates whether or not a reaction will occur. So, for instance, when the 2 things combine, can they form one substance? Will depend on whether or not it obeys the conservation of mass, right? The rule of the conservation of mass, law of conservation of mass. Beyond that, this is going to be described by the general reaction, which you saw last week, AX, where in synthesis reactions, these can be elements or compounds. A and X don't necessarily indicate metal and nonmetal in this type of reaction. This just represents 2 things kind of combining to become something new. Okay? Some examples. Like that. This is a general reaction type. So remember I said there's a greater category of synthesis reactions is that they combine to form one substance. Well, underneath the heading of synthesis, we can talk about elements that combine with oxygen or sulfur. They generally behave like this. Remember, oxygen and sulfur are located really close to each other on the periodic table. And so we could take the synthesis category and we could talk about a reaction that combines with oxygen, a reaction that combines with hydrogen, a reaction that combines with water. We could talk about several different kinds of individual types of reactions. We're not going to do that, but understand that there are several little subcategories, if you will. Okay. We will talk about some subcategories in some of the other types of reactions, but for now, I just kind of want to make you aware that this is one of the types of reactions that we've discussed. This is what it's generally going to look like. You're looking for 2 or more things on the left to become one thing on the right. Okay, it will always just be one thing on the right if it's an actual synthesis reaction. Okay. Doing pretty good. Okay. All right, let's do number 2. The opposite of synthesis reaction. a decomposition reaction. Where a single reactant breaks apart to form two or more. Again, AX is a compound. A and X can be elements or compounds. Again, reminding you that they must follow the general law of conservation of mass. Typically, we refer to these as the opposite of synthesis. Okay. Our example is the decomposition of mercury oxide. A really common example that's kind of cool is what we call electrolysis, where we take H2O, we apply electricity to it, and it breaks apart into H2 and O2 gas. That's a liquid on the left. Okay, one of the cooler types of reactions. From there, we've got categories like the decomp of metal carbonates. So metal carbonate breaks apart into a metal oxide in CO2. We've got the decomposition of metal hydroxides. So remember, subcategories. Where a metal, oops, let's do calcium, stick to calcium, that is attached to a hydroxide, metal hydroxide, also breaks apart into an oxide and water. Again, decomp of metal chlorates, so a metal. In the presence of heat and a catalyst, and oxygen. So we know a chemical reaction will occur here because oxygen gas will bubble out. We know a reaction will happen here because another gas will bubble out, and so on and so forth. So there's different little individual categories within each type of reaction. Now, do you need to know each individual category? At this point, no. but there are several, and all of them do the same thing, right? They take a big thing, they break it into smaller parts. A lot of times with decomposition reactions, we have to ignore the polyatomic rule. Right? So what does that mean? If you look at the left side, we've got a polyatomic ion that breaks up. So we can't just keep it a polyatomic on both sides. A lot of times, again, polyatomic breaks up. Polyatomic breaks up. So this is one of those reactions that you may not be able to use that special rule of when it breaks apart or when you go from left to right that you can keep the polyatomic. Same idea for synthesis reactions because they're the inverse of each other. Okay, let's move on to one of our more difficult, the single displacements. And I say more difficult because the single displacement reaction is also the thing you read about when you read about activity series. So we're going to learn how to predict not just what types of reactions there are, but whether or not a single displacement reaction can occur based on the activity series of metals, which is what you read in section 3. So the third type is the single displacement reaction, where one element replaces another in a compound from start to finish. They typically take place in an aqueous solution. And they are represented in one of two ways. In single displacement reactions, these general forms and we'll say for double displacement so I don't have to write it again. A and B always represent metals. For single and double displacement general reactions only, and X and Y are always nonmetals / negative polyatomics. Yes?
Why did it go way one? Why did they just flip? Why wouldn't X?
Oh, oops. My bad. Thank you for catching that. I got the other one right though. Good catch. The metal switches. Okay, so what this means is in way one we're saying a metal replaces a metal. Okay, whatever's being replaced has to be identical as far as type. The metal can only replace the metal. It should not replace the nonmetal. Same down here. The nonmetal can only be replaced by the nonmetal or whatever polyatomic you might be dealing with. Okay. Do we understand that these guys are all compounds? Anything with two things is a compound? Good. All right, so here's an example. And for these ones, I'm going to ask that you balance it in your notebook because you haven't had enough experience balancing equations, no matter what you think. Mix. So balance it.
Is that NO3?
Yes, that's an NO3. NO3 2, NO3 3. See it?
Or did you just ask me for it?
My sister probably did it. She just like handed this to me. So.
Yeah, Kat Rose said it today. I was like, right.
She can't even eat popcorn.
Why?
She's just still doing that. She's still having those things.
Yeah.
What can she eat? You say milkshakes and smoothies, I swear.
Ice cream. Yeah.
I think my little brother's having the same issues she has.
Just finishing the daily cube.
Like, he has a written equation.
Wait, what's that? Do you have a high test iron? Do you write it like that?
Yep, because it's present on both sides, right?
Yeah.
Yep.
Oh.
Very good.
No, I'm not. That's what I'm saying. Okay, now.
Okay, once you have it written down, don't look up until you're done balancing it. Did everybody turn in their problems from last week? Yes? Should have a grade in the grade book if you did, huh? Mm-hmm, from Friday. Good. Okay, so let's move to another one. Let's do one with the non-metal instead. So this is the example for a metal. For the non-metal, do the next one. That one was easy. That one's quick. Intentional. ER2.
Oh, I didn't see that.
ER is one of the diatomics. I feel like you guys get really upset when I give you crap, but I don't understand it because I'm going to be giving you crap for the next 2 years of your life, so. All right. So next thing we're going to talk about, and we're going to come back to single displacement reactions in section 3 in a pretty big way because we're going to talk about how to predict whether or not they will actually occur using the activity series of metals, which you read about, but probably didn't really understand what they were saying. So we're going to talk about that later. For now, I'm going to move on to the next type of equation, which is, of course, the double displacement. Did I get everything I needed? I did, right? Yeah, okay. So a reminder, I am going to write the just general form of the reaction for a double displacement. But the symbols need the same. So for instance, the A's are still going to be metals with the B's. Okay. All right. In double displacement reactions, the ions of two compounds exchange places. A and B can be either metals, which are always positive when they're ionic, and or positive polyatomics. And there's only like one of them that we know, or two of them that we know, right? So NH4. X and Y can be nonmetals, which are always negatively charged, or negative polyatomics. For these, one of the compounds that is typically formed is usually a solid, which we refer to in chemistry as a precipitate. The reactants are typically, and I use that term for a reason, it's not going to be an always. In chemistry, we don't deal in always and never. Reactants typically are aqueous to begin with. They can be, so you can also see that product can be pure gas. So right, so we can see solid, we can see gas, or a molecular compound, like water. Remember the term molecular compound? We read about it. We didn't talk about it, how to name them, but binary molecular compounds were compounds made of two or more nonmetals. So CH is a molecular compound. OH is a molecular compound. Okay, so let's look at some examples. So in knowing that one compound is typically a solid, a gas, or a liquid, or molecular in some way, the other thing is going to be aqueous very typically. Okay. When we get later in chemistry, like next year, we call these precipitation reactions, and what happens is we say a salt plus a salt makes a solid plus a salt, always. I talk about how we can just describe the thing that forms the solid, because that's really the only interesting part of this equation. More on that later. Okay? Hopefully you balanced it. Yeah? Hopefully that's how you balance it. Okay, and remember we said there are formations, there are those different subcategories. So this was a precipitate reaction. Okay, so here's another example. So another type of subcategory is the formation of a gas. And this one is aqueous. This one is a gas. Sorry, ran out of room. I write yours the other way. So that one forms a gas. That's the H2S, so the hydrogen sulfide. Blah, blah, blah. Formation of water. Please be balancing them as you go. It's good for you. That was easy. All right, then we do an acid-base reaction. An acid plus a base makes a salt and water. It's another subcategory. If you saw this on your own, would you be able to see that this was a double displacement reaction? Probably not without doing one of our tricks, right? It's one of our tricks. Now, do you see it? Okay. Remember, water can always be written as HOH, and I don't care which way you write it, but if you generally just write it as HOH, you probably won't go wrong. Okay. Our last type of reaction is the combustion reaction. We good? Woo! combustion reactions combine carbon hydrogen containing compounds, or take carbon hydrogen containing compounds, add oxygen, create carbon dioxide and water. This is our most common type of combustion. There are, I would say, at least 2 different forms of combustion reactions, if not more. The only other, so these are combustions of hydrocarbons. Okay, hydrocarbon implies it has hydrogen and carbon in it, and sometimes oxygen, right, like we talked about last week. The other type is the combustion of hydrogen. So this is like our exception to this general form. The combustion of hydrogen takes hydrogen, adds it to oxygen gas, and forms water. So this is a special form of combustion. It's the opposite of electrolysis, or the decomposition of water.
What does it say behind me?
Which one?
Oh,
Combustion of hydrogen?
got it.
Okay, so let's look at balancing a combustion reaction. We talked about the trick, right? The trick is that in front of the hydrocarbon, or the thing at the beginning, there will either be a 1 or a 2. Those are your 2 options. For something like go ahead and balance that one. Just practice. You with us? You okay, Braden? You look tired. Did you sleep last night?
Yeah, so I got like 6 hours of sleep.
That's not a lot.
That's a lot. That's like a good night's sleep.
No. Oh my goodness. You guys are crazy. Okay. So balance your reaction.
I didn't see the finish. I was wondering like why it was like right.
Like, why is everyone writing something down and it's really quiet in the room and I'm not writing anything down? That's practice. Yeah,
Are we at school tomorrow?
probably. We don't get lucky like that.
First thing I thought was-
Yeah, but it's like all overnight and we have plows, so. I'm sorry. I am sorry. Just hope for another storm between now and April.
Might have to run for snow Sunday night. It's like having those curves.
Ooh. I got it. When you're done with these problems, you're gonna upload them to Canvas for the January 25th exit ticket. Have a great day.